Okay, so we're going to do an example. It says example of T in action. Or we use the T statistic to analyze an experimental situation. Here's the experimental situation. 20 adults listen to 100 pairs of speakers and try to determine which is taller just by the sound of their voice. 100 pairs. They say the same phrase, like, hello, how are you? And then, hello, how are you? And you're going to pick, for each pair, who you think is taller just by the sound of their voice. 100 pairs. The number of correct responses is recorded. With no ability to determine the height, we should find that they're correct about half the time. I guess I put they should be correct, maybe. Half the time, so we would get a score of 50 on average. So here's the 20 adult scores for the 100 pairs. So of the 100, the first person got 65 correct, and so on. So most of these people beat the 50 number. This loser here was pretty close to 50, so maybe that person couldn't really tell height from sound of voice. But most people seem to do significantly, significant, I said the word, I'm not sure it's significant. They look higher though. It looks like you wouldn't get those kinds of scores, so if on average this should be 50. You can just look at it and go, those aren't scores based on a population whose mean is 50. So there looks to be some ability to judge height from voice. So in order to use the T procedures, we have to verify the assumptions. First one is simple random sampling. We have to find out how they picked these people. Hopefully they picked them in some random way that approximates simple random sampling. I think that's probably a reasonable assumption. Or these people might be college students, and maybe college students hear differently than ordinary people, so maybe it only represents college students, so that could be a problem. But simple random sample of some group, so this information represents the ability of some group. And then we need the normal distribution, so we'll do a normal probability plot. So I went into my calculator, I entered the data, and so I entered the data in list 1, say. I went to stat plot, I picked the probability plot, which is the last plot in stat plot. I put list 1 in for my list. I hit go. Of course, nothing happens. And then I go to graph. Where's graph? Yeah, graph. Then I hit. Then the picture comes up, but it's at the wrong size window. I hit zoom stat. I get this window. So I see a slight curve this way, so that would say a slight left skew to the data, but n is 20, which is pretty big, and T tolerates mild skewness pretty easily, especially with sample size 20. So we're going to go ahead and use a t-test on this data. We're wondering whether this information could have come from a population whose mean is like 50, no ability to determine height. So we go mean of 50 versus mean bigger than 50. Makes sense? If we reject this 50 in favor of the alternative, then it says that the average number correct long-term would be greater than 50, and that says long-term the adults can determine height better than guessing based on voice. So here's the T statistics, x bar minus 50, s over root n. Here's x bar and s off of my calculator. And then when all is said and done, you get 9.78. Okay. And then we want to use tables just because that's one of the things we do. So I'm in the tables here for a T distribution. And degrees of freedom is what? Not 49. That's sad. There's 20. Somehow I got 40. Don't ask 40. I got 49. I thought there was 50 pairs. But it's 100 pairs of speakers. It's 20 values. So degrees of freedom is 19. Well, that's okay. Glad I caught that. Otherwise, I have to be doing this all over again. So degrees of freedom, I don't have it in my notes. So degrees of freedom is 19. So I messed that up because I saw the 100. Somehow I thought it was 50. Don't ask me how these things happen. Degrees of freedom is 19. So I'll have to do this again. So I'm in row 19 of the tables, and I'm looking under tail probability 0.05. 1.729. So tail probability 0.05. We get 1.729. I have to triple check myself because I'm scared. Okay, that makes sense. So the one-sided critical t-value is 1.729. So the classical approach says I'm going to compare this number, 1.729, with my t-value, and it says t has to be bigger than that to be considered statistically significant. So anything bigger than about 1.7. 1.7 is like our 2 number. Okay. So it's a one-sided test, so it's ordinarily a little bit less than 2, which is what this is. You have to beat that number to be considered significant. I got 9.78. So the classical approach says we're going to reject HO at the 0.05 level, like that. And the conclusion then would be we reject, my hand rejects, we reject HO that mu is 50 in favor of HA mu is bigger than 50, like that, at level of significance alpha equals 0.05. And ordinarily what you do then is you're going to write something in context. So what's this mean in the context of the experiment? So it appears that people do better at identifying height the taller individual just by height, just by voice. Just by voice. Just by voice. Then they would just by guessing. So it appears that people do better at identifying the taller individual just by voice than they would just by guessing. And that's all a matter of comparing your test statistic value to the critical value and seeing if it beats it, which it does. So then you can reject the null hypothesis. Write down your conclusions, what level of significance, and then in context, it appears that people do better at identifying the taller individual just by voice than they would just by guessing. And so that's the classical approach to this problem, and on the next slide we'll look at the p-value approach. We anticipate the p-value to be quite tiny because this is quite a big value for t. So what's happening there is, here's t like this, and 1.729 is up there. Here's that small tail probability, 0.05, like that. And so all we need to reject the null hypothesis is for the computed t-value to fall in there. Reject if t is in there. And then, but what's going to happen here, 9 is way the heck out here somewhere. 9.78. And so when we compute the p-value, we're going to find the area of this right tail. It's going to be basically 0. We won't find it in the tables. We'd have to use a calculator to do it. But we'll see how that goes on the next slide.